All right, everyone, so we're going to do 4.2 and 4.3 together here in these notes. There's only 4 problems, and then there's kind of just 2 general and summary things that I want to talk about. So I'm going to limit the videos to about 5 minutes each, so I'll stop at around the 5-minute mark, and that way you can pause, go rewind. It won't be an overwhelming amount of information. So for our first problem, we have y equals sine of theta plus 1. Now, our amplitude is that number in front of the sine function, the absolute value of the number in front of the sine function. So there's no number there, so our amplitude is just 1. Period. 2 pi over b, remember we talked about this on last Thursday, that b is the number in front of theta, or it'd be in front of the parentheses. We'll see that a little bit later. If there's nothing there, it's just 1. So period is going to be 2 pi over 1, or just 2 pi. Your notes should say HS, so for horizontal shift. I just printed out an old copy. So for horizontal shift, there is none. If you look down at number 3, that's an example of a horizontal shift. It'll be in a parenthesis. So if there's not a parenthesis there, you don't have one. So we'll just leave that blank, and then our vertical shift is plus 1. There you go. All right, so we talked about this last week, that we take the period and we divide it by 4, and that's what we end up counting by. So we're going to count by pi over 2 on the x-axis. Makes our life a little bit easier in terms of the pattern. All right, so let's label out the x-axis and the y-axis, and then we'll talk about how to deal with the vertical shift, because the vertical shift's new. All right, so pi over 2, pi, 3 pi over 2, and then 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and then we'll go to negative 2 pi. You can keep going in the positive direction. I like to show you guys both the negative and the positive, just to see that it goes in both directions. All right, so I'm going to label the y-axis. I'm going to count every one, just so you guys see how the shift actually works. A little bit easier to see that way. Okay, so a couple things. This is a sine curve. We learned last week that sine starts at 0, 0, goes up, up, makes that up-down curve very nicely. So as opposed to starting at 0, 0, what this vertical shift does is it forces the graph, all the points on the graph, to move up 1. So if we were originally going to start at 0, 0, now we're going to start at 0, 1. And we're going to follow this up-down pattern with an amplitude of 1 given by the equation. So this pi over 2, it would usually be up at 1, but since we've shifted everything up 1, it's going to go up to 2. Same thing with the pi. Same idea with 3 pi over 2. 3 pi over 2 would usually be down at negative 1, shifted up 1 to come to 0, and then your 2 pi. We connect these dots with a nice curved line. It's beautiful. And we continue this pattern on the other side. Don't think about it too hard. Just follow the pattern, follow the symmetry, and it should work out. Okay, so that is our graph of sine theta plus 1. Looks great. Continues on for both directions indefinitely, but that is a perfect example of a regular vertical shift.